The second law of thermodynamics states that the universe is winding down. Over time, ordered systems inevitably decay, and entropy, or disorder, always increases. Under this law, the emergence of complex order is an uphill battle. The sheer density of information required to build an intelligent, living organism makes our existence an incredibly improbable statistical accident. This assumption sits at the core of the Fermi paradox. If intelligent life is a freak accident of chemistry, the math suggests we are likely entirely alone in a silent cosmos. According to the accepted laws of physics, human existence is a cosmic anomaly, fighting a losing battle against the inevitable decay of the universe. A cross-disciplinary team of researchers recently proposed that this bleak assessment is completely wrong. Mineralogist Robert Hazen and his colleagues view Darwinian evolution as a specialized instance of a much broader universal mechanism. They call it the law of increasing functional information. The hypothesis states that an inexorable drive to generate complexity is woven into the physical structure of the cosmos. If this proposed law holds up, the development of a rock, a planet, and a human mind are all driven by the exact same cosmic mechanism. To test a claim this large, scientists need a mathematical ruler that can measure the complexity of both a living cell and an inanimate stone. Biologist Jack Szostak defined functional information. Through random mutation, RNA strands twist into millions of shapes. Only a tiny fraction possess the precise geometry to lock into a target molecule. This chart calculates how rare these working configurations are compared to random noise. The universe naturally selects and preserves these functional configurations. Nature actively filters for systems that work. This selection process operates entirely outside of biology. It began shortly after the Big Bang, long before the first cell existed. As early energy cooled, quarks formed stable protons. Inside the nuclear furnaces of early stars, these basic particles were forged into heavier, complex elements. On early Earth, those basic elements combined and faced extreme environmental pressures. The universe selected for the most chemically stable arrangements, leading to the gradual evolution of distinct mineral structures. We can observe this non-biological evolution playing out right now on Saturn's moon Titan, which continuously generates increasingly complex carbon structures in its atmosphere. Biological survival of the fittest is just the organic translation of a much older physical drive towards stable, functioning complexity. To map this out, physicists use phase space, a theoretical landscape containing every possible configuration a physical system can take. Progress across phase space is not a slow ramp. Systems evolve until they hit a threshold and take sudden leaps, crashing upward onto a new, wider floor of possibilities. Like when early molecules formed self-replicating cycles, survival criteria instantly shifted to dynamic longevity. That leap set the stage for rapid biological phase transitions. Single cells acquired nuclei. The Cambrian explosion produced intricate bodies, and central nervous systems quickly followed. These jumps introduced new criteria for selection. Once molecules form self-sustaining cycles, the physics of individual stability gives way to the logic of the collective system, creating pathways that did not exist on the floor below. This self-reference reaches its peak in human cognition. By simulating future outcomes and running experiments within the mind, we generate our own feedback loops, a transition where technological evolution accelerates far beyond the pace of genetic mutation. Proposing a new physical law naturally draws heavy scientific scrutiny, and this idea is fiercely debated. Critics argue that functional information is highly contextual. It is incredibly difficult to objectively calculate and compare the functional value of an inanimate rock against a mutating cancer cell. Other researchers point to alternative models like assembly theory. They warn that applying the rigid thermodynamics of inanimate matter to the adaptable rules of living systems stretches the physics too far. Science is currently fighting to determine if this is a literal mechanical law of nature or simply a compelling philosophical metaphor. If Hazen and Wang's theory proves true, information must be elevated to a foundational physical parameter of the universe, sitting equally alongside mass, charge, and energy. This brings us back to Enrico Fermi's silent sky. If the universe naturally and inexorably selects for increasing complexity, the emergence of intelligent life is not a highly improbable accident. We are not a freak anomaly fighting the dying cosmos. We are the exact complex outcome the universe is structurally built to produce.